It is 2013, right? And you are standing on a sweltering beach in Indonesia.
Just a beautiful, completely unforgiving environment.
Oh, exactly. And your job is to drag this massive, incredibly heavy offshore oil pipeline out of the ocean and onto the land.
Which is, no small feat.
Right. So to do this, do you use a highly calibrated, mathematically modeled, multi-million-dollar piece of specialized machinery, or do you just tie the whole thing to a local bulldozer and hit the gas?
I mean, I know which one sounds better on paper, definitely.
We all do. But today, we are looking at a spectacular multi-million-dollar mistake. We are diving into a classic case of what happens when over-engineering and corporate risk aversion completely blind highly technical experts to the simplest, most effective solution, staring them right in the face.
It is just a phenomenal case study. Like, we spend so much time in modern engineering and project management worshiping complex systems,
Absolutely.
Trusting algorithms and relying on these heavy purpose-built machines. We assume that because a project is massive, the solution must be equally sophisticated.
Right, because big problems need big solutions.
Exactly. But the physics of the real world rarely care about how sophisticated your blueprint looks.
Yeah, the real world is messy. And the source material we are using today for this deep dive is just gold.
It's so good.
It is this obscure but deeply insightful 2019 blog post on a site called Pliforda Means Stronger. It was authored by a lead pipeline engineer named Matt Mosifer.
Right.
So we are going to explore this specific 2013 project in Indonesia, look at the actual physical mechanics of why the textbook solution failed so miserably, and help you identify where you might be making this exact same overly complicated mistake in your own professional life. Okay, let's unpack this.
Yeah, to really grasp the irony of this specific story, you first have to understand the broader context of where this blog post lives.
Definitely.
When you navigate to Matt's site, Pliforda Means Stronger, you are instantly confronted with a wall of intense, high-level technical expertise.
It's intimidating.
It really is. I mean, we are talking about a sidebar packed with tags for MATLAB, Python, numerical methods, advanced dynamics.
Particle kinematics.
Yeah, particle kinematics, genetic algorithms. You see sections dedicated to subsea engineering, 2D graph data imports, Orcaflex simulations.
It is not a casual read. It feels like stepping into a high-level computational laboratory.
100%.
This is the digital workspace of someone who makes their living solving massive infrastructural problems using intense mathematical modeling.
Precisely. And it even features contact information for a colleague who is listed as both a microbiologist and a self-improvement advisor.
Which is a wild combo.
It really is. But it represents this very specific ecosystem of highly educated, deeply analytical thinkers.
Right.
And that computationally dense backdrop is what makes the ultimate lesson of this 2013 pipeline story so profound. Because the hero of this narrative isn't a genetic algorithm.
Right.
Or a piece of advanced subsea technology. The hero is blunt force.
I love it. So let's get right into the dirt of the Belong in a Main oil line project.
Let's do it.
It is 2013. The client is Pertamina, which is the massive state-owned oil and natural gas corporation in Indonesia.
A huge, huge organization.
Massive. So our author, Matt, is in the early stages of this pipeline project, and he travels to a meeting in Timor, Indonesia, to discuss the logistics of the shore pulling operation.
Right.
Now, for an audience that follows heavy civil or offshore engineering, you probably already know the incredible physical demands of a shore pull.
It's an intense physical battle.
You are fighting the weight of the pipe, the friction of the seabed, and the tidal forces all at once.
And historically, the textbook, industry standard equipment for this operation, is a linear winch.
Right, a linear winch.
Mechanically speaking, a linear winch uses a continuous pull system. So it has these massive hydraulic grippers that alternate clamping down on a thick steel wire rope.
Just pulling it inch by inch.
Exactly. Pulling the payload continuously in one direction. But because it generates such extreme tension, it requires a massive stationary foundation.
Like a concrete block or something.
Usually a heavily engineered concrete or steel deadman anchor dug deep into the earth. I mean, it is precise, it is slow, and it is highly standardized.
But at this meeting in Timor, Matt gets a very different piece of local intelligence.
He really does.
The local engineering teams tell him that for shore pulls in this specific region of Indonesia, the standard practice is not to build a massive foundation and use a linear winch.
No, not at all.
The local standard is literally just to use a standard bulldozer.
Which is brilliant. It is localized, practical, and heavily reliant on dynamic vehicle weight rather than a static foundation.
Right. So Matt takes this ground-level intelligence back to an internal meeting with his team. He tells the top managers that, hey, the local guys just use bulldozers for this.
And the top managers completely dismiss it.
Completely.
The text actually notes they didn't think about it seriously. They immediately mandate that the team must locate, rent, and utilize a linear winch in Indonesia.
They just shut it down without a second thought.
What's fascinating here is the underlying psychology of that immediate dismissal. Like in highly specialized fields, simplicity can actually feel deeply threatening to a sense of professional expertise.
Oh, that's an interesting way to put it.
Yeah, in the minds of these top managers, a linear winch is a purpose-built tool. It has complex specifications. It belongs in a university textbook.
Whereas a bulldozer is just a blunt earth mover.
Right. They fall into this cognitive trap where they assume a specialized, highly engineered tool is inherently superior to an improvised, localized method.
Okay, I have to challenge you on that, though, because it is like going on a rugged camping trip and insisting on building a complex, calibrated espresso machine in the woods, completely ignoring the locals who are just happily boiling water over a campfire.
That's a great analogy.
But calling it just a cognitive trap or an ego trip feels, I don't know, a little too easy. Like, why do highly educated teams actually fall into this?
Well, there's definitely more to it.
Right. If you are a top manager on a massive Pertamina pipeline project, aren't you terrified of sheer legal liability?
Absolutely.
Because if you authorize a local guy in a bulldozer and the tension cable snaps and someone is killed on that beach, the very first thing the investigators will ask is, where was your standardized, certified equipment? So isn't the linear winch really just a multi-million-dollar insurance policy against institutional blame?
That is a phenomenal point, and you are absolutely right. The pursuit of the linear winch is heavily driven by risk transfer and liability mitigation.
Yeah.
It is the old saying, nobody ever got fired for buying IBM.
Right.
Nobody gets fired for demanding the industry standard linear winch.
Okay.
But the irony is that this exact pursuit of bureaucratic risk mitigation actually introduced far more operational and schedule risk to the project.
Oh, totally.
By insisting on the proper professional tool, they actually created a deeply unprofessional, chaotic situation.
Because they couldn't actually find a proper linear winch.
No, they couldn't.
They are in Indonesia looking for this highly specialized equipment to rent, and all they can find is an old winch. And the absolute kicker here is that this old winch has 0 drawings and 0 documentation.
None whatsoever, which is a huge problem.
Right. Because in the world of offshore engineering, and particularly when dealing with a state-owned giant like Pertamina, you cannot just drag a mystery piece of heavy machinery onto a beach and start pulling pipe.
You really can't. You need absolute certified proof of its safe working load, its mechanical tolerances, and its material integrity.
Here's where it gets really interesting. The managers demanded a textbook solution to avoid liability, but to do that, they forced their highly skilled engineering team to become administrative archaeologists.
Administrative archaeologists, I like that.
Right. The source details how the team had to spend a massive amount of time measuring, calculating, and creating the engineering drawings for this old winch entirely from scratch.
I mean, think about the mechanics of doing that. You could just take a tape measure to it.
No.
You were running stress calculations, estimating material fatigue, and building out massive safety factors.
All for a rented piece of equipment you didn't even want to use in the first place.
Exactly. And creating the drawings was just the first step of this massive bureaucratic cascade.
Right, the labor just explodes from there. After reverse engineering the documentation, they have to physically test the winch.
Which takes days, if not weeks.
And then they have to hire a third party to acquire official certification for it based on those tests and new drawings.
Boy.
And finally, they have to submit this towering stack of newly fabricated paperwork to the client, Pertamina, for official approval. How much time and money did this purely administrative theater actually cost the project?
It's staggering. And anyone who has ever worked with massive enterprise clients knows that approval is never a single step.
Oh, never.
The text explicitly notes there were a few revisions required. The paper trail becomes an entity unto itself.
It takes on a life of its own.
Yes. Weeks of high-level engineering talent, tens of thousands of dollars, endless meetings, all functioning purely as administrative theater.
Wow.
None of this effort moved a single inch of pipeline. It was entirely about satisfying a bureaucratic prerequisite that the local environment had already deemed unnecessary.
It is the ultimate manifestation of doing the wrong thing perfectly. Like, they flawlessly executed a documentation process that shouldn't have existed.
Perfectly said.
But as we both know, all the stamped paperwork, all the liability shielding, and all the client approvals in the world mean absolutely nothing if the physics on the actual beach don't cooperate.
Which brings us to the Belonging Coast.
Yes. The paperwork is finally approved. The team moves to the beach to execute the physical preparation.
Finally.
They do the trenching. They build the massive foundation required for this newly certified old winch to ensure it has that static holding power we talked about.
Right, the dead man anchor.
Right. They install the machinery, secure it for operation, and jump through every final hoop. They have done everything by the book.
The stage is completely set. And the tension is incredibly high because so much time, political capital, and money has been sunk into this single piece of machinery.
So they fire up the linear winch, they attempt the shore pull, and, well, the source text is just wonderfully, almost comedically brief about the failure.
It really is.
Matt writes, quote, "But the team working on that operation faced with some issues."
Faced with some issues. I mean, it is the most perfectly understated diplomatic engineer speak for a catastrophic operational failure.
Some issues. The winch completely fails to do the job. After all of that, it doesn't work.
Yeah.
And we really need to look at the physical mechanics of why. Like, why would a certified linear winch fail where a bulldozer wouldn't?
It comes down to the physics of the environment. Like I mentioned, a linear winch applies a slow, continuous, static pull.
Right.
It relies entirely on its foundation not moving an inch. But they are on a beach. They are dealing with saturated, unconsolidated marine sand.
Which is not exactly a stable foundation.
Not at all. Furthermore, a massive offshore pipeline sitting in a marine trench acts essentially like a giant suction cup in the mud.
Oh, right. You have incredible static friction and suction that you have to break before the pipe will even budge.
Exactly.
Ah.
If the static torque of the winch cannot overcome the initial suction of the seabed, or if the sheer force being applied causes that custom-built foundation to shift even slightly in the wet sand, the operation completely stalls.
It just gets stuck.
The winch is essentially fighting itself. To use an analogy, relying on that stationary winch in that specific environment is like trying to pull a heavy truck while standing on a sheet of ice wearing dress shoes.
That's a great visual.
You might have the muscle, but you have no dynamic footing.
But a bulldozer is wearing cleats. A bulldozer doesn't rely on a single stationary dead man anchor.
Nope.
It uses continuous dynamic traction spread over a massive surface area. It utilizes the sheer vehicle weight, and more importantly, it can leverage momentum.
Yes, momentum is key.
A bulldozer can physically lurch forward, creating the dynamic, torque-heavy jerk needed to break that initial suction of the marine mud.
And it can adjust its angle of pull in real time if the sand starts giving way. The locals in Timas knew the physics of their own sand.
They knew it intuitively.
Exactly. They knew a static pull wouldn't work as well as a dynamic rolling pull.
And the climax of this entire agonizing saga, Matt writes, and at the end, we used a bulldozer to do the shore pulling operation.
Just incredible. If we connect this to the bigger picture, it is a masterclass in the sunk cost fallacy colliding with the harsh reality of the physical world.
Definitely.
For weeks, they poured resources into the linear winch because they had legally and politically committed to it.
Mm-hmm.
They couldn't turn back without the top managers admitting they were wrong from day one.
Which nobody wants to do.
Never. But the ocean doesn't care about your corporate pretense, and the pipeline doesn't care about your liability shield.
Yeah.
When the winch physically failed, all of that administrative bloat evaporated instantly. They were forced to proceed right back to the very first provided situation offered in Timas.
They literally had to exhaust every possible complicated, expensive, highly documented avenue before they were finally given permission by reality to just do the simple thing.
And Matt specifically highlights this pain of trial and error as his core lesson. He recommends taking all local information provided at the early stage of a project incredibly seriously.
Regardless of whether it fits your pre-existing standard operating procedure.
Exactly. Because ignoring it doesn't just cost you money, it costs you immense energy, only to leave you exactly where you started.
To really drive this home, Matt anchors this blog post with a very striking quote featured prominently on the site, attributed to the mathematician Weierstrass.
It's a great quote.
The quote is, "If there is a smooth and tidy way ahead, passing from the old rocky roads is not recommended." So what does this all mean? For you, the listener, navigating your own professional challenges, how does this mathematical philosophy recontextualized the whole Bulldozer story.
It completely inverts our standard corporate assumptions.
Yeah.
Usually, when professionals hear about a smooth and tidy way, we picture the highly engineered, properly documented, officially sanctioned method.
We picture the linear winch.
Right, and we naturally assume the old rocky road is the improvised, localized, brute force method, the bulldozer.
Yeah, because it looks less polished.
But the reality of belonging proves the exact opposite.
The linear winch was the rocky road.
Exactly. The textbook solution was fraught with immense friction. It required reverse engineering, administrative bloat, endless revisions, custom foundations, and ultimately it failed.
It was a total nightmare.
That was the rocky road. The bulldozer, the thing that looked unrefined and unprofessional to the risk-averse executives, was actually the smooth and tidy way ahead.
Because it actually worked.
It was locally proven, instantly available, and dynamically suited for the specific physics of that beach.
That is a massive shift in perspective for anyone managing complex systems. True efficiency isn't about utilizing the most sophisticated tool in your tech stack. It's about finding the path of least resistance to the actual outcome.
Yes.
The goal of the project wasn't to successfully deploy a linear winch. The goal was pull the pipe out of the water.
Precisely. And this is where you, the listener, really need to audit your own professional environment. Where are you letting institutional risk aversion or the desire to look professional force your team onto a rocky road?
I mean, think about the architecture of your own daily work. Are there areas where you are insisting on a linear winch method?
We all do it.
Right. Maybe you are forcing your engineering team to adopt a massive, rigid, incredibly complex project management framework because the executives want a paper trail.
Oh, I've seen that happen.
When a lightweight 10-minute daily stand-up, your version of the bulldozer would actually get the software shipped faster.
That's a perfect example.
Or maybe you are deploying a hyper-complex, multi-layered enterprise software solution to track supply chain metrics that could literally be managed on a shared spreadsheet. We equate administrative difficulty with professional value.
That is exactly the trap. We think that if a process isn't painful, highly documented, and complex, it somehow isn't rigorous enough.
Exactly.
But Matt's experience in Indonesia teaches us that ground-level, localized reality will always outcompete theoretical standards. Listening to the people who actually work in the dirt or in the code early on is the ultimate shortcut.
Wow.
The smooth way is often the most glaringly obvious way, provided we drop our preconceived notions of what proper engineering looks like.
I really want that phrase to stick. We equate administrative difficulty with professional value.
It's so true.
So just to recap this incredible journey, we started with a massive offshore pipeline project in 2013. A local team in Timus offers the most effective, physically sound advice based on the local environment. Use a bulldozer.
Simple as that.
The top managers, driven by a need for standard operating procedures and liability mitigation, dismiss it entirely. They launch their team into a bureaucratic nightmare of reverse engineering undocumented equipment, begging Pertamina for approvals, and building custom concrete foundations on wet sand.
All for nothing.
All for nothing. After all that wasted time, money, and administrative theater, the static physics of the winch fail, and they use the bulldozer anyway.
They meticulously paved the rockiest road possible just to get to the exact same destination. And this raises an important question for all of us to consider.
Yeah.
When you look at modern enterprise culture, with all its endless compliance meetings, required documentation, and towering layers of approvals, how much of what we call due diligence or standard procedure is actually just an elaborate defense mechanism?
Oh, I love that.
How often are we building massive bureaucratic structures simply to avoid the vulnerability of trusting the simple, unglamorous truth right in front of us?
Wow. Is your due diligence just a defense mechanism against simplicity? That is a provocative thought that will totally reframe how I look at every project moving forward. We want to thank you so much for joining us on this deep dive.